Hw10 question 3. In this problem, we're reacting an acid with a base, and they give us both a volume and a molarity for both of them. Automatically, that means that we're dealing with a limiting reagents problem. They're giving you enough information about both reactants to figure out how many moles there are. And that will allow us, by determining which reagent is limiting, which type of ion is in excess. And that's the very first part of this, which you could click and guess, I suppose. But we're going to work through this in a systematic way. Let's start, of course, with a nicely balanced equation. We've got hydrochloric and barium hydroxide neutralizing to become water and a salt. And when we balance the equation, we need coefficients of 2 in front of both hydrochloric and the water. Let's note the information the problem gave us about volumes and molarities. Notice these are red numbers, so they'll differ from student to student. I've got, in my case, 69 milliliters of 0.451 molar hydrochloric acid and 218 milliliters of 0.066 molar barium hydroxide. If we multiply volume times molarity in both cases, we'll get the number of millimoles. And it's easy to work with millimoles because you don't need to convert from milliliters to liters, just multiply. So 69 times 0.451 gives 31.1 millimoles of hydrochloric acid, and 218 times 0.066 gives us 14.4 millimoles of barium hydroxide. Now, right off the bat, can I tell what's limiting? No, actually, in this case, I can't just say that 31.1 is bigger than 14.4 and therefore the barium hydroxide is limiting. I also have to account for the fact that there's a coefficient 2 and an implied coefficient 1. That means the coefficients are different. To make the comparison, we'll divide the number of millimoles by the coefficient for each of the reactants. So I'll take the 31.1 millimoles of hydrochloric acid and divide by 2 to get a number that will serve as a standard of comparison with that of barium hydroxide. And in the case of barium hydroxide, we just divide by 1 because the coefficient is 1. Now we can make a comparison. 15.6 as compared to 14.4. That tells us, whichever is lower in that case, tells us what's limiting. And in this problem, at least with my red numbers, the barium hydroxide is limiting. Making that determination is of crucial importance because it affects everything else that the problem is going to ask for. Now, one other thing that I've seen students make a mistake about in the past is they think that once they divide the 31.1 millimoles of hydrochloric acid by 2 and come up with 15.6, that is a number of moles or millimoles. It is not. The number of millimoles that we have on hand of each reactant is what we had initially found when we took volume times molarity. These other numbers are just serving to compare both the number of moles and the coefficients. It's simply a way of identifying the limiting reagent. Now, we can already address this first part of the question. What ions are in excess in the solution? Well, if we know that hydroxide is the limiting reagent, the barium hydroxide, that means all of the hydroxide ions will be used up. there will be no hydroxide left over in the solution. The other reagent, which contains hydrogen ions, will be in excess, and that means at least some hydroxide ions will be left in solution. So hydrogen ions is the correct answer, at least for the red numbers that I was provided in this WebAssign problem. Now to tackle the bigger question, what is the concentration of those excess hydrogen ions? To do that, we'll do some calculations based on the limiting reagent. We always base calculations on the limiting reagent. So we have 14.4 millimoles of barium hydroxide. We're going to figure out how many millimoles of the 31.1 that was initially present react along with the 14.4 millimoles of barium hydroxide. And to do that, we'll use coefficients from the balanced equation. There's an implied coefficient of 1 for the barium hydroxide, and there's a listed coefficient of 2 for the hydrochloric acid. Making that calculation, we see that 28.8 millimoles of hydrochloric acid react along with the barium hydroxide. So that many millimoles isn't present anymore. But that doesn't answer the question of what's in excess, or what's the concentration of the excess. If we had determined earlier that 31.1 millimoles of hydrochloric acid were initially present, and 28.8 of those 31.1 millimoles react away, we just subtract and get the number of millimoles left over. And in this case, it works out to be 2.3. So 2.3 millimoles of hydrochloric acid are left over after all of the barium hydroxide has gone away. Conveniently, the subscript for hydrogen within the formula of hydrochloric acid is a 1. So that means however many millimoles of hydrochloric acid you have is also the number of millimoles of hydrogen ions that are left over as well. In other words, you don't have to worry about making a conversion. You could see the case where there's a diprotic that is a 2-proton acid that is reacting with barium hydroxide, and if you have 2 hydrogen ions within that formula, then you would have to account for that in your calculations. But in this case, we don't have to worry about that. So we've got 2.3 millimoles of hydrogen ions left over. The question wants us to find concentration. So we'll do our little trick. When calculating molarity, molarity is normally listed as the number of moles of a substance per liter of solution. But we've got millimoles and we've got volumes in milliliters. The ratio of millimoles per milliliter is the same as that of moles per liters. So let's plug in. We've got 2.3 millimoles of hydrogen ions left over. We'll divide that by the volume at this point, which, this might be a little bit tricky. In order to produce this reaction solution, we added 69 milliliters of hydrochloric acid to 218 milliliters of barium hydroxide. To get the total volume, we always assume that you can add volumes together unless otherwise noted. We would add those. So 69 plus 218, which gives us 287 milliliters. And if we take 2.3 millimoles divided by 287 milliliters, we end up with 0.0081 molar.